I'm Joris Peels, and this is another edition of 3D Printing News Unpeeled. And today we're going to be talking about, well, MRO and the digital warehouse, the digital inventories. That is a really big thing. A couple of years ago, we were talking about how very few companies were paying attention to 3D printing and shipping, even though the big business case was good. And now this kind of development, especially with regards to digital warehouse, digital inventory, is really accelerating. What now is happening is a company called ABS, which is kind of advisory classification type company. They can classify as kind of certify kind of parts and processes for marine and offshore and things. And Hyundai Heavy Industries, a gigantic shipbuilder, Korean shipbuilder that can make you anything from a attack submarine to a oil, an LNG carrier, that kind of thing. CScam is a Korean, they're probably not so well known, Korean powder bed fusion company. And KITECH or KITECH, which is a Korean national kind of research institute, have gotten together to previously had an MOU, now they have a joint development agreement to essentially construct a digital supply chain, or to construct a digital warehouse for metal MRO parts on board marine vessels. So I think this is a really very exciting development. Of course, this is an alternative to Pelagos. Pelagos is by ThyssenKrupp, right? German steel company, and together with Wihelmsen, which is another German kind of global, kind of like, they're like RS components for boats. And they got together, they made a joint kind of platform themselves, and they recently partnered with Doosan. We told you that back then that this would probably lead to other companies and other companies in shipbuilding seeking alternatives, and this seems to be that alternative. They want to have a part identification platform, an evaluation platform, and a reordering and print platform, all that together. Now, this begs the question, what about other big shipbuilding companies? Are they all going to join one of these two alternatives, all going to make their own, or a certain giant company is going to kind of set the standard? Are they going to work together? What about a company like Maersk, right? How does that fit into this? Is it going to set up its own MRO platform, try to make its own parts? Where's the IP, that kind of thing? So there's going to be a lot of meetings, a lot of jockeying for position for this business opportunity, which is tens of billions of dollars a year. And think about this. Imagine you've got a boat full of some fungible things, some fungible commodities, something that'll go rotten or something like that, and it's broken for a couple of days. Imagine how much that is costing you day by day, and how much that's costing the shipping company, and everyone involved in that shipment. So this is a huge opportunity. It's still underappreciated. Still too few people are paying attention to. And please, if you're an OEM in the space, a materials company, please pay attention to this. Imagine if Hyundai Heavy Industry, for all of its repairs on all of the boats it makes, standardizes on a particular powder, right? They say, oh, okay, we're going to use Carpenter aluminum powder, whatever, right? Or some Korean company we've never heard of. That is a huge impact, because that is a stable source of a standardized continuous revenue. It probably, the margins won't be great, I'll tell you that much, but it's going to be a huge volume thing that's really going to make determine who can be a big volume player and can have these economies of scale in, for example, aluminum. Right? If it's going to be like a Korean consortium, only Korean firms, it will maybe enable all these people to make their own national consortiums. There'll be a Chinese one and there'll be a European one, and we won't work together. Or if these guys at one point in their platform at a part identification identify that this part is best printed with an ALS printer, or that this part costs $400 on an ALS printer, meanwhile it costs $350 on an SLM Solutions printer, they will then print them on these printers, and this will make a huge impact on the OEM market as well. So please pay attention to this. A little bit more about this CScam thing. CScam is a bit of an unlucky name. Korean company, powder bed fusion machines. They have like a small one, like 100, 150, 150, 100, 500 watt. And they also have a kind of medium one, 450 by 200 watt. Kind of the materials they have, kind of more industrial materials. And this could be a huge boost for them. This could be a huge boost for demand for them. They could actually be standardized on this platform, and this could really help them sell and service their machines all over the place. Now, what they want to do also, they're talking about part identification, the platform, great. They want to do onboard repair. I hope that's a typo or something like that. I don't think onboard repair. I think onboard repair with DED systems and other types of systems is a good idea, but I would not like to have a powder bed fusion system on on a ship. I just think it's with the powder plus, plus then the way the laser and all this kind of stuff. There's just too much danger. Fires, explosions, titanium fires are really terrible, but other fires are terrible as well. So I just don't think that's a really match made in heaven. But later on, we'll come back to another alternative. But I think more often than not, we really want to go to a place where we're doing wire DED, cheaper plus non-explosive, in conjunction with milling. I think that'd be a lot safer if you really want to do stuff on a ship. But apart from that, this is a huge thing. It didn't get a lot of press, and a lot of people wrote about it. I think it's gigantic because these companies, they move very slowly, but then they stay the course, let's say. So if this is their digital warehouse, this might be their digital warehouse partner forever. This might be their path into 3D printing forever. They might industrialize their whole supply chain on this. So I think this is a huge news. And so far, I'm kind of the only one, but hopefully other people will also think so after a while. So this is the meeting of the consortium, and now it's it's like a joint development project at the moment. We don't know how much money they're going to be putting in. We don't know where it'll end up, but I think this is a really very consequential move for powder vendors, for software vendors as well, for material vendors, for anyone in the space, because these guys are going to be getting up so much demand. And if all of a sudden this CCAM is their standardized printer, they're going to all of a sudden come out of nowhere and have a much better machine in years to come as well. So this is big news that you should not overlook. Okay, the next thing. Also, again, naval. The naval thing is really, really working. And this is Speed 3D, Australian company. They, at very, really high speed, shoot particles at a workpiece and then build up a super cheap object. One of these machines can make a ton, like literally a metric ton of stuff a year. And Speed 3D was kind of like a little esoteric Australian thing, until they discovered the expeditionary thing. So their idea of putting this thing in a container and using it for their own forces, of course, spread over Australia, a big area, and using it for the British forces. Via the British, they got introduced to the Americans, and now they're doing good business. They sold 6 of these things to Ukraine, and they're making parts on demand for the military in very, very forward-deployed locations. So this Speed really, really found its niche. It's cheap. It's relatively safe to operate, although it could be better, I think. And at the same time, the build speeds are really, really considerable, and it's relatively straightforward in terms of design and the things it can produce. It maybe cannot produce your, top of the line, bestest, thin filigree, mesh TP structure thingy-majiggy, but if you want something like a spare part of a tank, it's not a bad technology for this. So they've already been making inroads into the American Armed Forces. They've been doing stuff with the Naval Postgraduate School. The British Armed Forces likes them. So these guys are doing great. And they're basically on the back of this kind of alliance between the UK and Australia and the US around submarines and naval things. They are doing great. So this is another huge step for them. So basically, the Naval Sea Systems Command, and NAVSEA, which is taking a big interest in 3D printing at the moment, is doing something called SALVEX. SALVEX is in Naval Base Pearl Harbor in Oahu, and it is where what they're going to try and do is, together with the Naval Postgraduate School, have a Speed 3D in their offices. They're going to actually try to print spare parts for a ship underway. So the thing is, they have a Speed X Speed, so the machine, and the Speed cell, right, all combined on board that ship. The Speed cell is essentially some testing equipment, and I think a milling machine or a CNC. I think it's a 3-axis CNC, and so heat treatment on board that ship. And what they're trying to do is battle damage repair. So we're not only talking about, hey, we're underway. Oh, we're missing this part. Let's make that part underway. We're not talking about printing in the harbor or something like that and really quickly sending it by helicopter. No. We're talking about printing on the ship. And this is one thing I'm like, let's take a moment here, because it's the Navy, right? I mean, I can understand if I'm just some guy trying to transport bananas somewhere, but it's the Navy. They can deliver stuff worldwide very efficiently, especially if it's 2 to 100 kilo stuff. So, and to what extent, to what type of ship would this make sense, right? As opposed to just making it at a centralized location or one kind of mothership type of thing, and then expediting it via an aircraft, because the Navy has an option of doing that. And when other people there's one dude who has one banana ship. he really, really can't. So, at what point won't it be a much better idea to just get a drone to fly this part there or something like that? But hey, I love this, and I think this could be a really, really big deal for speed and a really big deal for industry. We know that the U.S. NAVSEA wants to put a polymer printer aboard like kind of all the important ships. So anything on the submarines, all the anything from like super tiny on up, and they want to put metal printers. They're looking at kind of Meltio, kind of metal printer type of stuff on board, like really large ships, like aircraft carriers, and maybe even a little bit smaller than that as well. So where does speed fit in this into this equation? Is it going to be alongside Meltio? Are they going to be up against each other? Are they going to be? Is it going to be a speed and a Meltio machine, or are they going to go for something else? I don't know, but it's a very, very exciting kind of area, and I think this is a very, very exciting experiment. And yeah, this whole idea of battle damage underway. That is huge. We've spoken about this before. Half the U.S. Navy at any one given moment is under repair. Half of it. Half of the ships the U.S. Navy has are being refurbished, repaired, damaged, not in use, and no one is shooting at them at the moment, right? So imagine how much that'll accelerate if people start trying to torpedo these things or whatever. So it's a huge problem for them. They know they're the biggest Navy in the world, the most advanced Navy in the world, but if they cannot repair these things or can't repair them quick enough, they're going to be sitting ducks. So this is huge, and this could be billions of dollars worth of business for DED vendors and for speed in particular. So I think it's a incredible opportunity for them, and I hope they do well. The next news is something a bit more esoteric. This is electrospinning. So electrospinning is a technology where you essentially drop an electric droplet on something, you electrify it and jet it. It stretches itself out, and then it basically gets deposited on something that kind of roller thing, and then it gets turned into a fiber. So electrospinning is kind of a new way. It's not super new, but I mean, it's a relatively new way of making fibers or making kind of meshes of things or making filters or some kind of new structure. So it makes a fiber in a new way, which means that we can make kind of disorganized but very functional structures in a completely new way as well. Now, what is electrospinning going to be used for? We don't really know. At the moment, new fibers, obviously. Things like filters, also in use, yes. New kind of textile type material or something like that, possibly. Batteries, all the stuff like that, maybe. Other things we really don't know. But the problem with electrospinning is it's kind of disorganized. A lot of engineering types don't like it. And it's kind of really expensive. These machines cost like 20 to 30K or 50K sometimes, and it's a big setup. So what did this team do? They did an article called Affordable and Customizable Electrospinning Setup Based on 3D Printed Components. This is an open access article in Physica Scripta, and it's done by, and I'm going to do my best I can with these names, guys, but Wojtek Skumal, Yuri Pekushek, Levent Parali, and Muterem Koch, right? I think. So that's available. The link is in below. So what they did is they made a programmable syringe pump, which is a key ingredient for this thing. It's in the middle. Usually that's like a $1,000 component or something like that, and they made that really cheap with 3D printing. They made the rotating collector. That seems rather straightforward, and a control unit and housings for all these things as well. The total BOM cost or whatever this is like around $2,000. So this is a big deal, guys. If you're in the electrospinning world, and if you want to do something really, really breakthrough in your university, imagine just for $2K, you can get a bunch of students to make this unit, and then you can do electrospinning research as well. I love this. I think it's wonderful. I think it's democratizing other research. We know 3D printing is good at this. We know that we're good at reducing the cost of lab instrumentation. There really needs to be more being done on like a more thingiverse for lab instruments and stuff like that. I think this is a hugely amazing business case. Anyway, that was the news today, and I hope you enjoyed that, found that useful. My name is Joris Peels, and this was thanks